All right. Unless
Tony,
Tony,
you're good to go.
Good. Excellent. All right. Thanks, Matt. Well, good morning, everybody. Thank you for joining us today. Again, as Matt said, my name is Tony Lauro, and the funny thing about about the photos, most Akamai employees when they first start, they're photographed, and those are the photographs that end up being used for your lifetime at Akamai. So for the people that have been at Akamai for 18 years, they look like babies on their badges and all of their material. So I've been with Akamai for about 6 years, and today I'm going to talk about DNS security considerations and look at some of the attacks and then countermeasures for those attacks. I'll make a disclaimer. I'm not going to go into things like DNS Sec and some other technologies. What I've chosen to do instead is to take things that I've seen in the wild working with clients, real-world examples, and then try to paint a picture around how those problems have manifested themselves, and then what you can do to defend against those same types of attacks in your own environment. So if you guys remember, February 9th, this was a couple years ago, an interesting thing happened. So if you open up your web browser and go to NewYorkTimes.com, you would have got this error, that the site cannot be reached. So on that day, I went ahead and I was like, okay, let me check some other of my favorite websites. Twitter's also down. Interesting. Then I opened up another browser tab, went to Reddit. That was also down. So I said, okay, let me just go to my site itself, and that happened to also be down. I asked myself, what could possibly cause this kind of disruption? Well, when you look at the error message, one part kind of caught my eye, and this is the part we're going to focus on. It says, mysite.com's server's DNS address could not be found. And not finding the address, that translation between the name of the website and then the IP address for that website is the key functionality of DNS. DNS has been around for 30 some odd years, and it hasn't really changed that much. Now, sure, there's been, DNS server software that's been updated over the years. If you guys are familiar with Bind, you'll know that there has been a lot of kind of systemic problems with how these services are implemented, and not to the fault of their designers. There is a certain trust relationship that exists within DNS that makes it susceptible to attack, and I'll talk about that in just a minute. So let's look at that request. When I go to mysite.com in my web browser, this is what's actually happening. So I'm saying, where is mysite.com? So my request goes out to the internet, and it hits the DNS root server system. The root server says, okay, this is a .com website, so let's point you to .com servers. So then the .com name servers say, okay, I have a record for my site, so let's go to mysite.com. And then, of course, the actual name servers that are responsible for responding for mysite.com are then fielding that request. And they say, go to this IP address. And then I get access to my website. So what we saw on February 9th, a couple of years ago, was a massive attack on a company called DNS. And DNS has been around for quite some time, and they're serving massive swaths of the internet for DNS resolution. So on this particular day, what happened was the DDoS attack occurred against DNS, the servers themselves, and for certain parts of the country that those servers actually were servicing, they were hit with an attack, and effectively access to any site that they hosted went offline. So the problem we face from a resiliency standpoint is, okay, now there's a lot of other factors here. Are any other DNS servers within region caching the entries for those host names, et cetera? I won't get into that, but this does pose a problem. If a site cannot be found, it might as well be offline. So I'm going to talk today about some of the other security challenges around DNS, and they mostly circle around people, processes, and technology. You see, we have years and years of legacy processes, best effort processes, and trust relationships and technical debt around our DNS services. And these services are, you know, by all accounts, one of the most important things that make the internet function. So I'll talk about some of the attacks we've seen, and then, you know, effectively what we have done to try to correct those issues. But not just what we have done from an Akamai perspective, but what you can do within your own environment. Now, the challenge here is that the attackers are sharing information. So we got this from an underground chat room. Someone's asking, what's the best way to DDoS a website if they have DDoS mitigation? They said, well, try DNS attacks. I hear they're all the rage these days. So this kind of information sharing is a good example of how attackers choose to target certain systems. One of the other things that we'll talk about in just a minute are certain vulnerabilities that exist in other systems that allow DNS attacks to be more fruitful. So these are the top 5. If you were wondering what are the top 5 considerations, these were plucked out of the ether by me. So they really are circled around the real big problem sets from a high-level perspective that we've seen. And in a couple cases, I deep dive into a couple real deep-level problem sets and attack examples that make these attacks possible and difficult to defend against. So the first one we're going to talk about is called the Leaky Faucet DDoS attack. So Leaky Faucet is obviously, if you've ever had a leaky faucet, you know how annoying this can be. But in this particular case, I'm making the distinction on a trend that I've seen attackers carry out, which is, okay, I know that as an attacker, almost every organization is now leveraging some kind of cloud-hosted service, right? And based on your agreement with that service provider, you pay for utilization. So for instance, if you're using a content delivery network and there's no other mechanism involved to stop this, and I query your hero image on your website 10 million times from 10,000 IPs, you're going to pay for every single time that hero image is served out of cache to those requesters. We saw a particular attack against one of our gaming customers in the APJ region, and this was a couple of years ago now. But you'll see on the graph on the right, there was a massive DDoS attack. It was multiple attack vectors, SYN flood and UDP floods against their entire subnet. And you'll notice it came in right away. It did not ramp up. It just was there all of a sudden, an onslaught of attack traffic. They were also targeting the DNS infrastructure, which is what this graph shows, to the tune of 2.1 million requests per second. So the question is, if your DNS provider can handle a sudden, 40, 50, 500x increase in DNS queries against its infrastructure, what happens to your monthly service charge if they were able to answer and respond to those query requests? So I put together a little graph. Again, this is me creating a visual. This is not created from any kind of customer billing data because we don't charge based on query response. So we don't really run into this very often. But from the customers that contacted me, this is what they saw. So you have a little spend versus utilization ratio. You'll see the monthly charge is very small in blue, and the DNS utilization takes up a certain amount of the total available usage. Now, when under an attack, and this can go on for weeks and months, we've seen DDoS attacks and leaky faucet attacks be very persistent over the course of weeks and months. But what you'll see, what happens here to the graph, is that DNS utilization goes up quite a bit, obviously. But another thing happens. We actually see the monthly charge expand exorbitantly. So the attackers are using this type of methodology. If they can't take you offline, they're going to hit you where it hurts, and that's in the pocketbook. So this is one particular use case. And again, the real goal here is to find a DNS provider that doesn't charge based on utilization. If they can afford to basically absorb those requests and respond and charge only based on a flat fee, that's the goal to where we want to get to. The number 2 attack is DNS Registrar Hijacking. Now, this is another interesting use case because if you think about the big problem with DNS in the world, your registrar is the one who should know what they're doing. Well, we saw a particular set of attacks coming in around the same time that we saw that Dyn DNS DDoS attack. And this was an attack campaign simply sending out phishing emails with Dyn branded email address, and the text basically made it look like there was a domain account that was suspended if you're a Dyn user, which is very easy to find out with a whois query. And those administrators were sent emails that said, hey, you have been suspended. Please click on this link and fill in this information to restore service. Now, there's obviously, if you think about it, it seems like, oh, who would fall for that? Well, in this particular case, we saw that just the simple process of bypassing actual security restrictions and attacking kind of the human element to get access to the registrar themselves, or targeting the administrators who manage the registrar access. And if you have a portal to your registrar for making DNS top-level changes, those administrators were getting targeted with spear phishing attacks. And then what happens is the attackers will manipulate the host entry for maybe www.yoursite.com. So the effective response here is, instead of having to hack your website, the attackers use social engineering and poor process management to create a copy of your website and then deface it. So this happened in a couple high-level cases with justice.gov and Troy.com. And again, there's nothing that can really be done to stop this except for creating more stringent policies around how your registrar portal is accessed. Maybe do you have multi-factor authentication? Do you have some other type of checks and balances? One of the ones that we recommend is a technical change, and this is client and registrar DNS locks. So if you were to query a domain that has client and registrar locks, this is what the response would look like. So it says domain status, client delete prohibited, client transfer prohibited, client update prohibited. And then at the bottom you have similar client and server registrar locks responses. So that's one methodology. The other methodology is making sure that whatever registrar you use, that their portal requires two-factor authentication, and that there is a stringent process around making changes to your domain entries. This seems like a very simple solution, and it is. But like I mentioned, that we have years of legacy processes that have just been ignored. Some of the other things to look at are, okay, well, when you register your domain, look into the privacy options. So there's anonymity and privacy options that allow you to register a domain, and instead of putting, Tony Lauro at akamai.com for the DNS administrator or the domain administrator, you can have that anonymized, and it would put, whatever registrar is serving your entries for you. So that forces people to have to contact the registrar and go through their stringent processes instead of spear phishing an administrator on your side. The other thing we've seen as a real common attack vector is attacking Apex domains. So this is kind of an interesting case as well, because most of the time when you think about how you're hosting your domain, you look at a simple process. You say, okay, I have some DNS servers on premises. And these are hosting my, my public DNS host names. So you'll see that the apex domain, as specified by RFC 1035, is example.com. So it's the domain name without any kind of forward entry or subdomain like www. Now, what's interesting about RFC 1035, if it states that, and this is not verbatim, so if you're looking it up, don't get upset, but it states that the start of authority is forced to direct DNS responses from a delegated domain server back to the authoritative name server for that domain. So effectively what this means is if you're using a cloud-hosted DNS service provider to manage or handle the front end of those DNS queries, if someone were to attack the top-level domain of your website, those queries would still have to be forced back to the start of authority for your domain and the authoritative service for your domain, which in this particular example here are within the data center. So this does a couple things. So you'll notice the robots at the top, they're attacking www.xyz.com. The cloud-hosted DNS service takes those entries and it fields those responses on behalf of the data center DNS server. But if I were to query the start of authority and the apex domain for xyz.com, which is just simply xyz.com, that request is forced to go from the attacker or from the botnet or whoever's doing this back to the data center DNS server that exists in the data center. So one, this could cause a DDoS attack to the data center itself. This could also obviously cause that DNS service to fail because it's probably not meant to directly handle all these queries from the internet. It also reveals information about your internal network and IP addresses on a subnet that you may have been trying to hide. So this is the type of an attack that we see quite commonly really be detrimental to organizations. The ultimate answer for Apex domain is to use an authoritative name server that can handle those top-level requests for you instead of having to send those back to your origin environment. The number 4 thing we're going to talk about is client-side DNS manipulation. And a couple of use cases that we saw here are kind of neat. It's always interesting talking to a customer and they get hit with something, and then you're like, wow, that's really cool. I mean, if it wasn't happening to you, it'd be really cool. But let's go into an example here. So one of them is from a few years ago called the Stegano Exploit Kit. And what Stegano was doing, it was basically hiding. If you guys are familiar with steganography, it first emerged in ancient Rome, where the leaders would basically tattoo a message on someone's head. This sounds very extreme, so don't shoot the messenger here. But tattoo a message on someone's head, let their hair grow back, and then they would send them to deliver the message. All the while, the message is hidden within their head. Well, steganography, in this particular case, attackers were using it. They're compromising third-party advertisers, and within those images, they were injecting malware. And how they were doing that was effectively injecting malware into that image so that when they would click on the link would take them to a third-party site that would download another piece of software called DNS Changer. And what DNS Changer did was it would effectively run on the client's machine based on vulnerabilities that the client machine already had in a browser or Flash or PDF. It would execute this malware, which would then scour their internal network looking for routers that had default credentials to log into those routers and change the DNS locations that were being pushed out to the local network from those routers. Now, this sounds awfully complex. Proofpoint did a great write-up, which I have linked below. But this problem is a very systemic problem because this is actually looking at two separate scenarios. So one is the compromise of a third-party advertisement. And when you look at how DNS Changer works, this is really mandating that we need to have some kind of control over how recursive requests from our environment or from our clients go out to the internet and are not manipulated with. So I'll talk about a couple use cases here. So one is the idea of script management. So knowing what third-party scripts are running on your website is a big piece of the puzzle. Now you'll hear, this is how Google will inject analytics tracking, et cetera. But you'll hear a lot about content security policy headers. The blogger Brian Krebs says that he browses the internet on a virtual machine because although he trusts the publications he's going to, all of the other third-party scripts that are loading on those web pages from other providers, he does not trust those, and he's worried about that concern. And we did a write-up a little while back at the end of 2018 about an attack called MageCart, which is effectively working the same way, and also some information about how to implement content security policy headers. This was another attack called Ghost DNS Changer. And this was actually a botnet that worked kind of like DNS Changer did. And this botnet emerged in 2018, and it had a few different capabilities. It has several different modules as part of it. One of them is injects JavaScript into a browser session. Another one effectively takes any kind of popular social media site, and if compromised, when a client on this network where this router is compromised, it will redirect the request for maybe Facebook.com to a copycat version of the website that the malware owners own. And when you log into that website, it would collect your credentials and keep track of all your user-supplied input. This is a flow chart of how that works. Effectively, just like DNS Changer malware, this was targeting certain routers that had default credentials attached to them. So most of the affected router firmware was for products sold in Brazil, as this particular case actually occurred. And you'll see some of the firmware there, D-Link, TP-Link, a lot of well-known brands. But effectively, the malware would log into the routers themselves, and then it would change their DNS settings so that any outbound request from any client behind that router would go through their systems, right? So again, this highlights the need for, when you look at protections for this, it highlights the need for recursive DNS resolution management, if you will. So the idea of recursive DNS is to say, okay, when a request leaves my machine and it goes out to the internet, before that HTTP connection even establishes, how can I check that this request is not making a call out for malware payload to a DGA domain or fastflux domain? And then when I leave that environment and I leave this trusted environment, maybe at a corporate location, how do I use client-side software to force those requests that go out to the internet to also go through my own DNS resolution name servers? So those are a couple different techniques for that. The last piece that I wanted to talk about was network-based DDoS protection of the IP space that hosts your DNS services. So when you look at most providers, they'll probably say something like, hey, we have 1 terabit per second of capacity. Well, if I'm going to launch an attack against an IP address, I can do this with a number of different botnets on the internet, and they effectively either reflect requests to a spoofed source IP address, which in this case would probably be your DNS server IP address. And when those responses come in, they can reach, I think the largest attack right now we've seen is 1.35 terabits per second. So we've seen a lot of customers come to us and say, well, my DDoS provider said that they had 1 terabit per second of capacity. And then we started to dig a little bit deeper, and we saw that the consumed capacity of a lot of these service providers was actually upwards of 60, 70, 80%. So the consumed capacity means any traffic they're already routing, any kind of mitigations that they're already doing on a regular basis. And what that leaves is a much smaller available capacity to handle these types of attacks. So before 2015, when Akamai acquired a company called Prolexic, our DNS services effectively relied on us having the ability to absorb requests into the DNS service, the DNS network, right? So when we saw query floods and any other types of attacks against our DNS services, we handled those from an application perspective. After the acquisition of Prolexic, we said, you know what? If someone were to flood the IPs of the networks where our DNS servers were located, that could probably cause a potential issue. So what we did is put all of our DNS servers behind the network-based DDoS protection of our Prolexic platform. So when you are evaluating an organization to do network-based DDoS protection against your DNS servers, performance is always going to be the big factor. So when you look at the last mile connection after a service or a request has been scrubbed and network traffic has to be delivered back onto your location where your DNS servers are, you want to make sure that there is, there's scale and capacity to handle these large attacks, but also in-region resiliency and redundancy so that you can have traffic backhauled between scrubbing centers, which is something we do, but also you have the ability to say, okay, the local POP where this scrubbing center is, we have a direct connection on the backbone of the network that you're on with your ISP. That actually allows you to reduce the performance impact, even while under attack, of those attacks as they come in against your DNS servers. So, we talked about a few of these things. Being able to absorb an attack from anywhere in the world where it comes from is part of the big piece of the puzzle. But when targeting DNS, the attackers are going to try to use a massively distributed attack methodology. So it's really important to have some scale and resiliency there. So these are the top 5 things. There are a whole bunch of other ones to talk about. I really would love to hear what you guys think. And, in terms of solving these problems with the 3 kind of main technologies we have, people, process, and technology, here are another couple of things to look at. When employees leave and transition from role to role, you got to make sure that they don't have access to the registrar portal. And there is a bunch of other things here that I'll leave as a takeaway for you guys. Also at the bottom is a link to a pretty comprehensive DNS security health check blog post that we wrote a few months back that I think would be really helpful. So thank you guys very much. And I'll go ahead and open it up to questions.
Thanks, Tony. I will unmute everybody so that we can entertain and field any questions.
Although we don't control it.
There's somebody.
Matt, you may want to mute everyone and just have somebody raise their hand if they have a question. Then you can unmute them individually, possibly.
Yeah, give me a sec. It's always a little dodgy.
Yeah. Well, that's to be expected, no problem. But, also I'll make another statement, too, that, you know, this format is a quick 30-minute, overview of these problems. But you know, we have seen a lot more types of attacks and a lot of different attack vectors. I'd be curious to see if anyone in the audience has seen any of these attacks against their own infrastructure and what they did about it. All right. Well, there may not be any questions right now.
Here,
which is okay.
Hey, Tony, I've got a couple for you.
Yeah.
Can you give a little bit of insight into DNS's role in a beyond corp, or more simply put, coffee shop type of architectural model?
Yeah, that's a great point. You know, I touched on it briefly in terms of looking at recursive, answering recursive DNS queries. And the whole idea of like a coffee shop model, or if you have, you know, a hotspot within your organization where you have guests coming in, or even for your own internal employees, DNS is a critical piece of that communication process. When a request leaves your environment, it's going to make a DNS query out to the internet, whether it's good or bad. If you were to look at answering recursive DNS responses for your organization, you can actually start to apply things like acceptable use policies, where you could say, hey, no pornography or gambling, you know, but you could go to a pharmaceutical site maybe, I don't know, depending on what your business structure is. But looking at those responses that go out to the internet help you, one, get a grasp of what your users are doing and how they're going out to the internet, what they're trying to do, but also unknown requests that may leave a user's machine based on a malware infection, or if they clicked on a phishing email, et cetera. Those kind of outbound requests are often hiding a lot of information. So they're using encoding to basically hide the URL that they're going out to, or maybe an attack might use an outbound DNS query to exfiltrate data within that DNS query. So there are a lot of different attack vectors, but yeah, for a beyond corp type zero trust model, DNS is definitely a huge piece of the puzzle, and not normal DNS, but recursive DNS responses, which means any request leaving your environment before the HTTP connection establishes, you have a chance to evaluate the fidelity of that outbound request, and if it should be connected to that web server, or if you want to serve a custom response that says, you know, not today.
And Tony, building on that, how complex of a change is it to improve your overall DNS posture?
You know, I think there's some kind of procedural type changes to improve your DNS posture from an external perspective. You know, certain things like don't host both internal and external host entries on the same server, because an attacker can query your public-facing DNS server and get the name of internal hosts, which is an information gathering technique. But from the recursive perspective, it's very easy to implement these types of solutions, because you're effectively just changing where your DNS resolvers are pointing your clients to. I think the important thing that I mentioned as well is when a client leaves your corporate environment, do they still maintain the same level of protection, you know, to intercept and evaluate those outbound DNS queries? And that's where it's pretty important to have some kind of client-based system that can run on your device, even your mobile device for that matter, that forces the DNS request to go through a trusted DNS server and not through some kind of copycat server or DNS Changer malware-enabled server. Does that make sense?
Does to me.
Excellent.
Any questions from the group? We have a few minutes left here at the tail end.
Okay, we see one here. What's it?
Oh, there we go.
Yeah.
Go ahead.
What's the best way to protect Windows Server 2016 DNS servers behind a firewall with forwarders set to ISP's DNS servers and root hint servers? Thought it was to put Linux spine server between Windows and firewall. Any other suggestion? Well, a couple points to make there is, one, to make sure that you have some kind of separation between your internal DNS server and the host that it's actually responsible for. I mentioned that just a moment ago. Is just to make sure that you're not actively fielding requests for both internal and external host names. That's probably the biggest thing. But two, there are a lot of different risks at play here. So one, the top level, Apex domain request attack is definitely, would most likely be at play here. So that Windows 2016 DNS server, if that is handling the authoritative request for the domain, any request that you're trying to offload to your ISP would still need to be handled by that local DNS server. But if you're talking about outbound requests, which it sounded like you were hinting at as well, the biggest thing is when your clients leave your environment, do they have that same level of protection? So, if you are forwarding requests from your internal servers out to your ISP to handle those DNS queries, what happens when someone goes home? Is that same level of protection or performance enabled for their home connection? And I know nobody wants an extra client on their machine, but in terms of DNS and just kind of the impact of any kind of fraudulent activity there, I would highly suggest some kind of recursive DNS client to help with that process. And that's really to kind of maintain that seamless experience between, being on net within the corporate environment, and then when you travel or you're at a Starbucks hotspot, et cetera, maintaining that same level of security. I hope that helped, John.
Great. Thank you, Tony. Anybody else? We've got a couple minutes left, literally, before we go our separate ways. If anybody has any other questions, I've got Tony's and my email up here. We wanted to give a final thank you to our partners, AEC Group and AT&T, for helping drive attendance and sponsoring today's event. If there are any questions that you think of after the fact, feel free to drop Tony, myself, Pete Stripes, your local Akamai, AT&T, or AEC Group rep a line, and we will get it answered as soon as possible. One final call, and if there are no further questions, I will stop the recording and have a great rest of your day. Thank you, Tony.
Thank you, and thanks everyone for joining. Appreciate it.
Appreciate your time. Take care.